has a half-life of about 24,000 years. Okay? All right? And we're going to start with 5.3 kilograms of plutonium because that's what you need for one nuclear bomb. That's what we're going to start with. And that's our ring there. It's that, and I'll show you it again. We're going to start with that. See that? That's 5.3 kilograms of plutonium. That's what you need for a bomb. Okay? We're just going to go into how it decays over time. We're not going to look at the bomb or anything like that. But here's what happens. You start with a ring. Here's my terrible drawing. I'll do a terrible drawing of that. But it's kind of like that, right? And then, after one half-life, you have half of it. See there? There's half. I'm trying to draw half. Does that make sense? After another half-life, you have about a quarter of it. And so on, right? After another half-life, you have an eighth about. Isn't that right? Because you keep getting half and half and half. But this is what half-lives mean. You start with this, and then you have half of that, then you have half of that again, and half of that again. So this is the whole, okay? This is the whole amount. Then you have half of that, and then you have half of that, which would be, what's a half of a half? 1/2 of 1/2? 1/4. What's 1/2 of 1/4? 1/8. 1/2 of 1/8. Right. 1/2 of 16th. And so on. 1/32. And so it just gets half and half each time. Does that make sense? But that's the concept. Okay? So this is the amount. The amount of plutonium. Okay? And we're just going to look at the half-lives. Okay? So this is after one half-life. We have half of it left. After two half-lives, a quarter left. After three half-lives, an eighth left. After four half-lives, 1/16 left. Make sense? So that's what's going on. Can you all see that? And I need to, God, between the thing and all the things and everything, and stop. Go away. God, just, what is, ugh. All right. Okay. So we start. So this is half-lives. Do we all get the concept? That's the concept, right? Okay. So now I'm going to do this. I'm going to make a little mathy table. So we're going to look at half-lives. And then amount. Now, initially we start with 5.3 kilograms, don't we? After one half-life, what do we have left? Just figure it out and write down the answer. There's a number of ways of getting it. We could divide by 2, couldn't we? Right? What else? How else can you get half of 5.3? Can you multiply it by 0.5? Or a half? Right? So I'm just going to do it this way because it's going to work out as we go. Times 0.5. Okay? Or a half. Same thing, right? Actually, let's do a half. After two half-lives, and that was 2, did we all get 2.65 kilograms remaining? Did we all get that? Right. After two half-lives, what have we got left? You can go, you can go, or think of it this way, it's half of what that was, isn't it? So 2.65 times a half, let's say, or times 0.5. Wouldn't that give it to you? Right? So if we just go 2.65 times 0.5, we get 1.325 kilograms. Are we all clear that it should be that because it's half of that and then half of that again, right? We all clear in the concept? So the whole was 5.3 kilograms. This is in kilograms. And then we went to 2.65 and then we went to 1.325. 325. You all clear? Is everyone following this? It's the important part. You all following? No? Yes? No? Yeah, okay, good. Okay. Okay, so the trick is, here's the trick though. Here's the trick, like you're mentioning on it. How can we derive a formula? Because we want to know, we want to be able to figure it out for like 10 half-lives, 1.7 half-lives, or, we want to be able to figure this out for 7.99 half-lives or 1.36 half-lives or whatever. We can't be just doing 1, 2, and 3. It's not. We need to be able to figure it out for any number of half-lives. And so that's why we need the formula, right? You already told me that 2.65, do you all agree, was 5.3 times 0.5. Did you all see that? Okay, so look at this. 2.65 is 5.3. It's a half of 5.3, or it's 5.3 times 0.5, right? It's a half of 5.3, isn't it? Now, so on the second half-life, I've got, I get 5.3, I get half of that, and then I get half of that again. See, I get it twice. Right? And then that's another way of doing it. So we can all do that, like, 5.3 times 0.5 times 0.5, and we get 1.325 kilograms. Okay with that? 3 half-lives, everybody get it. And more importantly, think about how can I make a formula from this? How can I calculate what if that said 30? What would I do then? And in fact, I'm going to ask you to then calculate it for 10 half-lives next. So we'll do 3 and then we'll do 10. But we need a formula here. That's the trick. We need a formula, right? So for 3 half-lives, we get half of this again. So you can go, this times a half. Or can I get it starting with 5.3? Because can't we go because this one is 5.3 times a half, and that's 5.3 times a half squared, isn't it? If you use exponents, right? So for this one, right, can I go a half? That will be the first half-life to get the 2.65 kilograms. And then times a half again, that'll give me the 1.325 kilograms, won't it? The second half-life. And so for the third half-life, don't I just multiply by half again? Isn't that all I have to do? Now that's the key. If we can see this, then the whole thing is easy. Because this is the hardest part, actually. Yeah, yeah. Well, I mean, yeah. Yep. So we've got 5.3, and how can I write this with an exponent? 0.5 to the power of what? Right, because it's 1, 2, 3. So 0.5 to the power of 3. Now, if you can understand this, then you've got it. This is the hardest part of the whole thing. If you can get that, because the rest is, I hope, is going to be easy. Because then you just go, well, how do I get for 10? So that's for 3 half-lives. So what's remaining after 10 half-lives? Yeah, you just go 5.3. You can get half of it. What's that? Because look, in fact, think about it this way. I've got to get, after 1 half-life, I've got half left. Right? Remember, think about the concept of the plutonium, which again, it looks like this. So we've got our ring of plutonium for a nuclear bomb, okay, right? And half of it is going to decay every 24,000 years, right? Yes, and then another half is gone, and then another half of that is gone, another half of that is gone. So we get half of it for the first half-life, then a half again for the second, a half again for the next, the third, and then a half for the fourth, a half for the fifth, a half for the sixth, a half for the 7th, 8th, 9th, and 10th. So we have 10 halves being multiplied. Oops, and I didn't show that. 10 halves being multiplied, right? So that's why it's actually 5.3 times a half to the power of 10. Right? Or 0.5, same thing, right? 5 to the power of 10. And in a calculator, you can just write it like that. 5.3 times 0.5 to the power of 10. Or you might, like, in your calculator, it might be 5.3 star 0.5 to the power of 10. That would also work, right? But your calculator knows PEMDAS, so it'll do the exponent, and then it will multiply, right? So you can trust your calculator to do that, right? But that's for 10 half-lives. What did that amount to be, or any of these? Desmos.com. Everybody, if you have the internet, look. DE, can you spell this? DESMOS. Done. There you go. There's your calculator. Desmos, done. Desmos.com. It's right there, yeah. That is an online calculator. It's free. Scientific calculator. Desmos scientific calculator. I'm teaching you right now. Watch. 5.3 star 0.5 to the power, that's the little hat that's above the 6, to the power of 10, enter, done. Right? That's the answer, right? I'll do it again. 5.3 star 0.5 to the power of 3. Let me send you the link. I'll put it in the Zoom chat. Can you see? Okay, let me get the Zoom chat going wherever it is. Oh, there it is. Okay. Okay, so there's the link for Desmos. You can click on that, right? But what you need to type into Desmos is this. 5.3 star 0.5 little hat 10. Done. Right? That's it. Yep. Yes, the little hat gives you the exponent. Yep. So in any case, no problem. So we've got, like, for 3 half-lives, so for 3 half-lives we got 0.6625, 0.6625 kilograms, and for 10 half-lives, I'm just going to round that to, it looks to be about 0.005, right? Kilograms, which by the way is just 5 grams, because there's 1,000 grams in a kilogram. So kilograms to grams, just move the decimal point over 3 spots. Sorry, now I'm not showing my paper. Okay, so look, 3 half-lives, you should have got that. 10 half-lives, you should have got that. Are we clear on this so far or not? Anybody else? Anybody lost? No, just waiting. Okay, so years. Back to our table, because you have to deal with years, right? 1 half-life is 24,000 years. How did I know that? How would you possibly know that? Right. You should be given that. You can't just know these stuff, right? So figure out what 2 half-lives is. Nobody shouted out. I want everyone to write this down. I want everyone to write down on their paper. Do not shout it out, because I want everyone to have a chance to think. If 1 half-life is 24,000 years, then 2 half-lives is what? And just write it down. So 2 half-lives is going to be 48,000 years. Does that make sense? Okay. 3 half-lives, again, write it down or calculate it. That's fine, but don't shout it out. Everyone write it down. Give you all a chance to think about that. This is 1 half-life. That's 2. What's 3? Write it down. Take your time. No rush. Hi, Matt. 70 students. I'll be there in a sec. 72,000 years. Okay? Okay. And 10 half-lives, believe it or not, would be, give you 5 seconds to figure it out. 5. What's 10 half-lives? Is that clear? 240,000. Why do we want to know all this? Because what if they told us how much of your 5.3 kilograms is going to be remaining? Uh-oh. after, you know, let's say 30,000 years. Now we're in trouble because we're not given the half-lives this time. So how do we use our formula? We have to figure out how many half-lives that is. That's the problem, right? Right. And so here's the deal. There's different ways of doing this, but look, if you take 48,000 and you divide it by what to get 2? 48,000 divided by what gives 2? So, and just think about this. Everyone think about this. I'm just going to try to lead you into the answer here. That gives 3. Okay. 24,000 divided by something gives 1. I'm just trying to lead you into the answer. Just write it down. What number unites these things? This over this gives 1. This number over this gives 2. This number over this thing gives 8. The same number on the bottom of these 3 fractions will work these things out. What is it? Yes, 24,000. Because that's how you're going to figure out how many half-lives this is. You go 30,000, watch this, 30,000 divide by how long a half-life actually is, 24,000, and put it in a calculator, and it should give you 1.25, right? 30,000 is 1.25 half-lives. And now we can use our formula. We're done, you know? So getting the formula and then understanding this. Now, look, doesn't it make sense? 24,000 you all said was 1, 48,000 was 2. That's a little bit more, 30,000 is a little bit more than 1, isn't it? So doesn't it seem right that it'd be about 1.25? Right. Just for fun, and so on. So to get the actual amount remaining, you just use your formula. 5.3 times 0.5 to the power of 1.25. And that's it. That's how much is remaining after 30,000 years. Okay? And I just can't resist doing one more. 80,000 years. 80,000 years. It's just going to be 80,000 over what to get the number of half-lives. Take your time. So anyway, we'll do those two. And then I'll have to move on to Math 70. Sorry, Math 70 students. Sorry to keep you waiting. So for 30,000 years, it was about 1.2 half-lives, and from the 5.3 kilograms, we had about 2.2 kilograms remaining, okay? Roughly, to 1 decimal place. Okay, so for 80,000 years, we got to convert it to half-lives, divide it by 24,000, right? Divided by 24,000. 24,000. And get about 3.33. I'm just going to use that. And I go 5.3 kilograms times a half to the power of how many half-lives it is. It's about 3.33. Right? And if you plug that in, and does it make sense? Because look, 72,000 was 3 half-lives. Remember that? So 80 is a little bit more. It's 3.33. That looks right, doesn't it? That looks right. Good. So plug that in. And by the way, I can use arrows on my calculator, and I can press enter, and I can just change the numbers. 3.33. I don't have to type it all in again. Okay. So roughly 0.5. I was going to 0.5 kilograms. About a half a kilogram. Because everything is a little bit off in this thing anyway. It's not exactly 24,000 years. And, nothing, so anyway, point is, there you go. And so back to our plutonium. After 80,000 years, if that's 5 kilograms, which by the way, 5 kilograms is like, it's about 11 or 12 or 13 pounds, mentioned 13 bags of sugar, and now we end up with half a kilogram, which is like 1 bag of sugar. So you went from something that weighed about 13 bags of sugar to 1. Does that make sense? So you just got a little bit left after 80,000 years. Not much. All right? And it just disintegrated, it decayed on its own.